This is one side of the formula sheet that you were given for actually all of the module courses we have from pre-algebra through college algebra. And in this particular module, we have really focused on quadratic functions. So I'm doing a little short video here to show you about the quadratic functions. And so there's a box right here, and I'm going to zoom in on this box. And we're going to talk about each of these things. So, quadratic function, f of x equals ax squared plus bx plus c. That's the standard form of a quadratic function. Or we can have f of x equals a times x minus h, that quantity squared, plus k. This is known as vertex form. And then a little bit more information for you down here. For the vertex of a parabola, it's hk, and these are the same hk that you see in the vertex form of the quadratic function. Here you can figure out how to find the h value for your x coordinate for your vertex, and then this shows you how to find the k value or the y coordinate of your vertex. Here I have transferred over the standard form of a quadratic equation and some of the other formulas from your formula sheet, and actually given a little bit more information. F of x equals ax squared plus bx plus c. We know that our vertex is hk, and quadratic functions are U-shaped graphs, which means that they're either going to look like this or they're going to look like this. And the vertex is the point in the center. In this case, it's our maximum. This is hk. This one is hk. It's either our maximum or our minimum for this function. So it's at a crucial point when you're trying to graph a quadratic equation. And then the axis of symmetry is a vertical line that goes through that vertex. So it's the equation x equals h. When your equation is in the standard form ax squared plus bx plus c, you can find your vertex by using the values for a, b, and c, similar to what you did when you plugged numbers into the quadratic equation. And you don't have to memorize these. These are on your formula sheet. So h is equal to the opposite of b over 2a. Your k value you can find two ways. There is a formula, and it's given to you, c minus b squared over 4a. Or you can find f of h, which means basically once you find your h value, you're going to plug it in up here for the x squared, the x, and then you'll solve your equation. My preference is this one. I would prefer to plug it in, but the formula is given to you, so that's fine too. The only other way to graph a quadratic function is if you are in vertex form, which is the one I'm going to look at and talk about next. So here you're going to see f of x equals a times the quantity x minus h squared plus k. And you're going to notice this is vertex form. That's what we call it. And so vertex form is really the easiest way to pull out your vertex as an axis of symmetry because it's there. You can see it. So the vertex is the hk in this equation. And then, of course, your axis of symmetry is equal to h. An important thing to know is if you do not have an x term, just a single x, then you actually are in vertex form. And that can look a little bit different, because you'll notice that we can write this multiple ways. I could have just f of x equals ax squared. So that is one way to write it. We could have f of x equals a times x minus h squared. We could have f of x equals a times x minus h squared plus k. we could actually have f of x equals ax squared plus k. So there's a variety of ways that it can be written, but you'll notice in all of these situations, you don't just see a single term with any x's. Because in reality, on these two, that x is going to get squared. So in this first example, if I come over here, my vertex is actually 0, 0, because I don't see a number connected with my x value, and I don't see a k over here, but I still know that my vertex is 0, 0. For this particular problem, my vertex is going to be h, because I will have an h value, but my k value is 0, because I've added 0. This is the most straightforward one, because you see the h and you see the k. And here, you don't see your h value, which means your vertex x coordinate is 0, k. So you have all of these different options that you have there. Now, if you want to take something that is in standard form and put it into vertex form, you have to complete the square to do that. In the actual lecture video, I have done that in a couple of those problems. Personally, I don't complete the square if I don't need to. So if I have an equation that is already in vertex form, I'm going to go with it. I'm going to find my vertex by identifying what the h and k are, and I'm going to go through the process to figure out what other values or questions it's asking me. If my equation is in standard form like this, I'm going to use these formulas. I am going to figure out what h is, and then I'm going to plug that in and figure out what k is. I'm not going to take the time to complete the square on the problem. I think it takes just as much time to complete the square as it does to just go ahead and use the a, b, and c in the problem to figure out what your h and k coordinates are. Another bit of important information that I want to talk about. When we talk about quadratic functions, this is one of the functions you're learning to graph here, along with lines. You've learned to graph lines if you've taken math up until this point. And then when you get into college algebra, there's going to be different other types of functions that you're going to graph. But the patterns that you're starting to see with these quadratic functions are going to be patterns that are going to continue as you look at other types of functions. So when I look at f of x equals ax squared plus bx plus c, there's a lot of information that I have in this standard form of the equation. The fact that it's x squared, I should know what the general shape of that graph is. So when it's a quadratic function, it's going to be U-shaped. It's going to either open up or it's going to open down. And I actually know which one of these is happening just looking at the equation. And that's whether it's in vertex form or whether it's in the standard form, because I'll put vertex form in here for you really quick too. And my h looks a lot like a k. Notice that in both of these situations, we have an a value. So that a value tells me if it opens up or down. So it's going to open up if a is greater than 0, which means a positive number. It's going to open down if a is less than 0 or if it's a negative number. It'll also tell me whether the graph is wider or narrower, fatter or skinnier. I'm not going to talk a lot about that right now, but that a value tells you basically your rate, how fast it's either expanding upward or it's expanding downward. But I do think, because you are going to graph these functions in this last little module, you need to understand by looking at the equation whether your graph is supposed to be opening up or down. That's going to help you kind of determine whether your answer is correct or not, because you're going to be plugging in a lot of values to help you graph these different functions. And that's true in every type of a situation. Every type of a function that you're going to be looking at from here forward is going to have some type of an a value. So just keep that in mind. This vertex form is something that talks about shifts. So for example, that vertex form is going to tell me that h value is basically a shift right or left. And then the k value shifts up or down. So those are two big pieces to understand too. H shifts right or left, K shifts up or down. On this screen, I have drawn a quick little axis, just sketching it out for myself. I've got a t-chart over here to plug in values for it, and I've got the most basic quadratic function that you can have. F of x equals x squared. All right, so it is in vertex form because it only has an x squared term. My vertex in this case is 0, 0. I'm pretty sure of that, but if I want to plug it in, I can figure that out. If I plug in 0, and I have y here, but this really is, this could be the same thing as y equals x squared. But if I plug in 0 for x, I'm going to get 0 for y. Let's go and graph that one. So there's 0, 0. And I'm telling you that's my vertex. Well, you'll see how that comes out here in a minute. And then I'm just going to choose values on each side of it. And I'm going to choose an x value of 1 and 2. And then I'm going to go the other way and do -1, -2. So this is 1 squared, which is 1. So that's the point 1, 1. So that's right there. If I plug in 2, 2 squared is 4. So if I go over 2, I'm going to go up 1, 2, 3, 4. When I plug in -1 and I square it, I get 1. So that's to the left 1 and up 1. When I plug in -2 and I square it, that gives me 4. So if I go left 2, I go up 4. And this is the most basic quadratic function you can get right there. So when I talk about shifts and I talk about opening up or down, we don't see it, but there is an imaginary 1 there. So if I were to write this out in function notation, so you could see all of the different pieces in the vertex form, it would be 1 times x minus 0 squared plus 0 squared. That's going to simplify down to that. So this is our h, this is our k, this is our a value. Notice the a value is positive, which means it opens up. We have our hk. So this is basically what we call our parent function. And so anytime we change the a value, the h value, or the k value, we change the way this function looks. So an h value, like I said, h is going to shift it left or right. A k value is going to shift it up or down. And then the a value is going to tell you whether it goes up, opens down. It also will tell you if it gets skinny or fat, because sometimes we're not going to be growing at that same rate. So that's a lot of information that you can get just from an equation before you ever go and actually graph it. And you need to really try to get in the habit of finding that pattern and recognizing that.